Sound. Yeah? I'll try to keep it off the wind. It looks like I'm not talking to you, that's why. I'm Adam, also Red, depending on when you met me. I go by both. My handle on RC groups is Red HLG. I've been flying since HLG was a thing and there was no DLG. So I'm old. I don't look old. That's what I like to tell myself. Hand launch is amazing. Thermals are amazing. Soaring is amazing. I love it. And any of my apostles will agree that I'm into it. And I'd like everybody else here to be into it too. My goal is to get people comfortable with flying and understanding and not be frustrated. I've met 3 or 4 different people here in Ohio with some really crazy, falsehoods that they were told about thermals. One guy, there aren't any thermals in Ohio. There just aren't any. It's too whatever, windy, flat, which is not true at all. We were just in one 5 minutes ago, so that we dispelled that rumor right away. Another rumor was, what was it? Oh, you should fly in the evening. That's the best time for thermals, when the ground's all settled and letting off its air. No, that's one of the worst times to fly thermals. Unless there's a storm front coming through, you aren't going to find anything in the evening. So we'll work to dispel some of those rumors. But first, safety first. There are a lot of trip hazards around here. These little cables that hold the tent down so it doesn't blow to Cleveland are trip hazards. There are holes. There's some sinkholes over here towards the road with sticks sticking out of them. There's various holes when you're walking around out here. Super careful. Sunburn. Don't get sunburnt. I know it's cloudy. I know you're all tough. But I have some lotion there. Alexi's holding it. There's a spray bottle over there too. Help yourselves if you didn't bring any. Stay hydrated. I got drinks. The big cooler has water. The smaller coolers have soda. Help yourselves. Everything's free. This is all donated by myself and Alexi to encourage you to come back and keep doing this. I started doing contests out in Seattle. It was just 4 or 5 of us. Within 10 years, there were 20, 25 people at just about every contest, 5 contests a year. We invented Discus Launch Glider out there. We had 2 or 3 manufacturers come out of there. We've had some world-class competitors as high as, would Joseph finish 3rd place, I think, come out of that club, just because I wanted to go ahead and hold some contests. So, that's what I'm after here. And there's also give the man a fish. He fishes or eats for a day. Teach him to fish. He spends thousands of dollars on a bass boat and fishing gear. So that's my approach to this. I thought I'd start with thermals, just so we have everybody's interested in thermals. And then I'll focus down to hand launch and some of the other things. And then I've got a whiteboard here. Professor Weston will start going. Alexi's actually got a doctorate. I'm sure he'd love to get on that whiteboard. Yeah, let's just start with thermals, and then we'll go around and meet everybody after that. So a thermal is a column of rising air. And there's lots of analogies for it. I think the important thing is, here's a buzzard here. We'll keep an eye on him and see if he finds anything. A thermal, in our perspective, our useful analogy is it's a gathering of all the warm air in an area, and it comes together and forms a column. So why does it do that? The model that I like to think of is the sun's hitting the ground and it's heating up different sections differently. And so the things that are a little black might have a little more warmth or pieces of grass, and things will be different temperature, and the air nearby them heats up. And when air heats up, it wants to join with other air molecules because they're all working together to move against the cold air that's coming down. And so much like a hot air balloon, but with a lot less organization. So how does a hot air balloon work? You put a bunch of heat into it with kerosene or whatever they burn, and it goes up into the volume, and it fills up, and eventually it gets enough mass that it can lift up off the ground. Thermals are not dissimilar from that. All the air molecules, for whatever reason, will come together and form a group, and then they'll start forming a bubble or a column. And then another bubble will be over here, and that bubble will join with this bubble, and they'll start getting all warm and friendly. And as they get more together, the cold air pushes away and the warm air joins together. And it all comes in to a column. And so let's say, another analogy is sort of like if you ever watch a pot boil. There's little bubbles that will just start in different random places, and they'll come together, and then it'll pop up and go up to the surface. It's a little bit like that. So that's a little different medium, but similar to that. So on a dead calm day, those air molecules will start coming together, and depending on how hot it is above that air, it will form into a column of warm air, and then that column has a finite distance, and it usually breaks off. And so imagine you're making one of those big bubbles, and it fills up for a while, and then it comes loose, and it goes up on its own into a column. And so thermals will sort of do that. They'll form on the ground, and then they'll move downwind, and then sometimes they'll stay connected to the wind, and sometimes they'll gather some of their buddies together, and then it'll break off and form downwind. So another characteristic of thermals is once the wind starts blowing, you'll get where the thermal will move downwind with the wind. One of the analogies is a river of air. That's old Buzzard's flying guide. We'll talk about a river of air, and that's a good analogy. So when a thermal forms over here, usually between these end trees and that other big tree you drove past, that's the best spot for thermals here on this field with this wind direction. They'll sort of come around the edge of that, and then they'll float downwind, whatever the wind's doing. And that's really useful for us because we can't necessarily see the thermals, so if we know what they're going to do, we can anticipate a little better what's going on there. So wind's going to have this column of air, and not only does it move it, but it also stretches it due to the boundary layer of the earth and some other things. The top of the thermal is further downwind. It's moved a little further down than the bottom of the wind, so it's a diagonal column. And so I just saw it last night. I wish they were doing it right now. A bunch of buzzards were lined up here, about 15 of them. The thermal had caught on the edge of this tree line, and the lower ones were further upwind towards the front of the trees, and the higher ones were further downwind. And there was even a hawk way at the top, a couple 100 feet up. But so that column there, and so when you come into a thermal, if you're higher than the planes that are in the thermal, you want to start further downwind. So what was I going to talk? Okay, our senses. How many senses do we have? Okay, I got one hand up with 5 fingers. You can actually use all of your senses to see a thermal, to possess a thermal, to acknowledge a thermal. Another characteristic that I didn't mention is when that air is going into a column, it sucks air towards it. And so again, on a dead calm day, the prevailing winds can be influenced by thermals. And so if there's a thermal here at Alexi's tripod, the wind is going to point towards that. The wind's going to flow towards that. And so if I'm standing here, I'll have wind at my back. If I'm standing over here, it's coming in on my side. And if I'm over here relative to the thermal, it's coming into my face. And so that's a really good notion to have in your mind, is that thermal is sucking in air. And depending on the activity around you, you may or may not notice it. When it's super windy like this, it's hard to sense a thermal that's even 5 feet over there. But what's neat is you can, when there is a wind, you can start doing some vector math to figure out where the thermal is. And so what does that look like? So the thermal's here, and when there's no wind, the air's all pointing right towards it. Okay, now we're going to add a prevailing wind here. And so what happens is if you're if you're right here relative to the thermal, the green vector and the blue vector add together, and you feel really strong push that direction. Now if you're down here, the blue vector and the green vector add together to resolve just a little wind to the down. And so this is the resolve vector. And so you know that the wind is dying down, so it probably is behind me if I'm facing this way. And then when you're over here, this vector adds with this vector to point like that. And so you feel the wind is at this angle here, and although it might point to this angle, you need to correct for the thermal. And so that's an important construct here. And so same thing here, these vectors add to be at an angle. And so it might feel like it's, if there was no wind, you might think it's here, or sorry, you might think it's here, but actually it's here. And so you have to account for that wind. And okay, so that's another important concept that'll help us with our 5 senses. So the first one is touch. What can you touch? So like I was saying, when that wind blows, how can you sense the wind blowing? Well, you can feel it on your hands, the back of your legs, your hair if you have any, or lack of hair if you don't have any. That's a touch, and you can feel that wind shifts. Feel that right now? Feel like it came calm all of a sudden? Okay, there's a thermal, right? You hear it, it's probably over by the cars. And it's gonna come, it's gonna move over us, it's probably right over us now, and then there's gonna be a fill. There's gonna be a big, strong gust behind it that pushes it on downwind, and that's the 2 vectors adding together. Okay, so touch, we're feeling it. Although back in the old days, they used to tell you to wear shorts and short sleeves, but that was before the sun was killing everybody, so throw that away. Wear a really thin thing that you can still feel the wind through. So touch. What's the next sense? What's a really hard one you want me to stump you on? What? Smell, okay. So again, with the wind vector, see all those brown droppings out there? That is literally cow poop that they've spread on the field. And when the thermal's over here, I'll smell the cow poop, when most of the day I haven't smelled the cow poop. So you'll smell that. You also smell trees and exhaust and other things that'll get caught in the thermal and blow it around. That was a harder one, but it is a thing. Okay, then seeing's too easy. What about hearing? How do you think you hear a thermal? Yeah, so there's a couple of things. The wind noise is definitely something. If you're standing next to some trees, you'll hear it rustling as the thermal pulls across it or pulls into it, or the lack of rustling when it's over the thermal. Another one you'll notice is like the road noise will change because of the thermal being between you and the road noise, if you can sense something like that. That one's really subtle, but that is another way that you can hear. What haven't we covered yet? So the taste, can you taste the thermal? That one's harder. My analogy there is the pollen dust and things like that are carried when the thermal. Sometimes you'll get a little bit in the back of your throat or a little taste. That one's really subtle. So taste, not so much. So seeing, seeing's the really easy one, and it's really the one we use the most. And there's a lot of things to see when you're looking for a thermal. So I'll go in order of the most useful. The absolute most useful is your buddy is in a thermal. Go where your buddy is. Go poach his thermal. That is #1 guaranteed. If it can hold up his sailplane and you're flying a similar sailplane, it'll hold your plane up too. Don't crash into him. We'll talk a little bit about that, but go find your buddy. Next best thing is you see a buzzard circling in the thermal. That's really good. Buzzards, when they see a thermal, they have some different motivations, so I'll cover that, but they will penetrate over. They'll fold their wings back to penetrate better. That's their better penetration mode. And then when they hit the thermal, they'll put their wings out far, they'll stretch their fingertips, their wingtips, and then they'll start a circle. And depending on where you live, they circle different directions. Our ones around here always circle whichever way works best for them. I haven't noticed a preference, but I've heard different birds have preferences. And then they'll drift downwind. And the tricky thing with buzzards is they don't stay in thermals super long unless they're looking to migrate or really go somewhere. They usually are trying to stay relatively close to the ground so that they can smell the dead things. And so they don't get super high typically unless they're going somewhere. And so you'll see them, particularly, I see them about 6 p.m. out here. They'll all get into a big group. And it's sort of like the last thermal of the day. That's what I think of. And they're going to get back to wherever their house is. And so you'll see them group up and go really high and then scatter. And then when they migrate down south, it's really fascinating. I saw about 75 in a thermal way off to the south here. And they all grouped up, again, duskish time, and took off. And then if the weather's changing, you'll see them group up too and use the last thermal. One time I was out here, and I didn't realize it at the time, but there was a front coming, and a big wall of clouds was coming. And I saw all the buzzards who'd just been hanging out all group together and get in this one thermal and take off. And it was just amazing. And I realized that was the last thermal of the day. And they could see off on the horizon these clouds coming. And they knew this was going to be the last thermal of the day. So they took full advantage of it. And that bag's gonna, I guess it's going. You get it, Daniel? So they could see off on the horizon that this cloud formation was coming. And okay, we'll use it as a thermal indicator. See what direction the wind's blowing? Downwind. Okay, so that's buzzards. Okay, there's other birds that also use thermals. The smaller birds, the swallows, and a bunch of the smaller little darty birds will use thermals. And what thermals do is when they're coming up off the ground, they'll pick insects up. And they'll concentrate those insects. And so the birds really like to use those and you'll see them circling. And so those are really good indicators of particularly low thermals, is when those birds are picking up dust or bugs in the thermal. Next thing that you'll see sometimes is some dust. You'll see the thermals pick up dust sometimes. That's a lot more common out west. I'd never seen a dust devil until I moved out to Seattle. And so you don't see too many of those, but on maybe a recently plowed field that's really dry, you'll see some dust devils around here. That's intense. You'll see smaller dust, and the polarized glasses really help with that. You also see the cottonwood trees that will have little fluffs that'll pick up in the thermals. So we're moving down the chain of usefulness. And then the next useful thing is the indicator on your transmitter. And again, we'll do that vector math that I was talking about. And it'll generally point to the thermal or to the side of the thermal, as we pointed out. And then the flags are really good too. I haven't put up my thermal pole yet. I have a pole that has a long stringer on it that shows the wind as well. Any other sight ones that I missed? So anyway, that's the 5 senses. Taste is the most useful. You taste one. But yeah, like I said, point to where your buddy is. And so when we launch, we're going to, if we don't know anything, I like to launch, and if I can, go at about a 45-degree angle to the wind. So the winds are pretty much down the runway. So I would point probably towards the sweet spot over here between the big trees and penetrate until I see the plane do something. And what does the thermal look like? Okay, there's this. So this is another thing you'll on the vision side. This is the Vortex 5. She loves the thermal. She's super light, even with 120 grams of ballast in her. So I'm flying on this vector, and what I really noticed, particularly when I was new to this, was there's a certain attitude that the plane flies for a given speed and flap setting. And if you do a lot of dead wind, dead air kind of flying, you'll appreciate what's pretty normal for your plane. And then when there's a thermal, when you come into a thermal, the tail tends to come up, and the whole aircraft will start rising. Now, why that's important is if it gets a gust or an elevator bump, it does more of a nose up. That's not necessarily a thermal, maybe, but not necessarily a thermal. That's more of a gust and you're coming into your elevator. You did some elevator stuff that you didn't realize. But when the tail comes up, that's a really positive sign that your plane's in some lift. So that's a really good one when you're first learning, is look for that tail coming up. But then, since it's a column of air, as you come into it, you may have just one wingtip bump. And so if my box is a thermal, I'll come here and the wingtip will bump. And it'll almost push you out. This is a column of air. It might want to push you out of it. And so that's an important thing to notice. And then if I'm on this side of it, it'll come here. And it'll push me out that way. And then the other things are going to be sometimes your rudder will turn somewhat as the vector switches on you. And you're looking for a difference in your plane. Now, there are gusts and bumps and other things out there that aren't thermals. And you might turn on stuff that isn't there. And that's just something you got to train your lizard brain on. If you want to, when you're learning, turn on everything. Turn on every little gust. See if it works. See if anything happens. But generally, that's you're going to find that there's some gusts out there that aren't related to thermal. Okay, so we're coming in. So we're going to come straight into a thermal in this first one. The box here's the thermal. So we're coming in, and the tail comes up. Okay, if you straight on, tail comes up all by itself, the thermal's here. We'll try to get a circle going, because the thermals aren't very big. They're never as big as you want them to be anyway. And you start a thermal turn. So nice circle. And what you want to do is keep paying attention to your airplane. What's it doing? Is it going up on the whole circle? Great. You're in the thermal. Keep doing that. If it will take it, give it even more elevator. Climb a little more. Give it a little more flap. Give it more lift. More is good, because you're in a thermal. You may not be in a thermal forever, so you want to try to get as high as you can for a given thermal. And so you're cranking up. You're staying in lift the whole time. If it's all the whole circle's up, that's awesome. You've done it, you're centered, keep doing that. If the whole circle isn't up, well, try to recenter your circle a little bit. So if only one half of the circle is going up, move the whole circle towards where that is. And so if let's call it the box here, or the plate. So if I'm in the thermal here, everything's good. I'm turning, now it's not so good. Okay, so I'm gonna try to turn in a little bit more and get into that thermal so that the whole circle is lifted. And maybe the thermal's not big enough for that, but usually they are, particularly with hand launch. And so think about what your plane's doing and what it's doing well, and where the best thermal action is, and then try to center your plane in that. What else? Okay, and so then we talked about drifting downwind. You can see your plane doing the good lift, not good lift thing, but you can also assume that you're going to drift downwind. And you're going to drift as fast, not quite as fast, it's a little less fast than the wind itself. You saw how fast that bag went down the field. The thermals don't drift quite that fast, but it's nearly that fast. And so when it's this windy, you're going to be going downwind quickly. And so you want to keep moving with the speed of the wind and anticipate. But again, keep an eye on your circle. If you start falling out of it, sometimes the thermals go away. They love to do that in Muncie. I have a heck of a time staying in thermals in Muncie. They don't break apart quite as much here as they do there. But more likely, you've circled out of the air and or out of the thermal, and you should work to recenter it. And so usually I like to go downwind first to use my altitude to find it, because I can't go downwind forever because I got to get back to the field. So my first initial look, if I've lost it, is downwind, circle, and then come back upwind into it, hopefully. And then further away first, and then closer last, and see if you can pick it back up. And that's a real skill. Thermaling far away is even harder than close to you. So keep practicing. Is it going to rain on us, guys? Yeah. Is there a radar pointing to it? 10 minutes. Okay. Let's take a little break to put some of the stuff that can't get wet away. And then we'll move under the tent. And then if it's too crazy, maybe we'll all get in our cars. But yeah, let's go ahead and prepare for that. And think of some questions. And I'll field them once we get back on target here. To the right side is the stronger part of that one. And the lower part of it. And off to the right is the higher part. See how fast they're moving? They are moving crazy fast because it's so windy, but also because there's good lift. Yes, they adjust. And it's something I'll talk a little bit more about later is your performance with speed changes and with ballast. And they don't ballast, they don't have any extra weight, but they do have that variable geometry. They can change your camber, but they can also change their wingspan and how much frontal area they have. And if they want to be a rock, they can pull their wings all the way in. But they don't touch the ground unless they want to. So they're good workers. And then they also don't want to flap. That's a waste of energy. And they worked hard eating that carrion. They don't want to waste it by flapping. And you'll see the eagles around here will thermal some. The juveniles, the younger ones, the ones that don't have their bald head yet, are terrible at thermaling. And so you see them flapping a lot more. And that's something that they learn as they get older, how to do that better. Hawks are a big one around here. They like the thermal. They're looking for something on the ground sometimes, so they have some different motivation. But They also like to go places. Osprey too, out here. And then the seagulls are another good one. They'll actually go up in large groups, and particularly towards the lake and in downtown. They hang out a lot downtown because where all the garbage is. So you'll see them. Crows, occasionally you'll see them in a thermal, not too often. And then some of the littler birds will thermal as well. I don't see too many falcons out here, but occasionally you'll see falcons doing that. So any other questions I can field? How many thermals? It's pretty variable depending on the day. When it is a perfectly calm day but good lapse rate. Lapse rate is it's warmer down low and cooler with altitude. So the cooler it is at altitude, that's a better lapse rate. When you have good lapse rate, you could imagine that there's a checkerboard kind of pattern on the ground, and the white ones will go up and send their thermals downwind, and then the black ones will light up and send their thermals downwind. And so I usually think of there's a couple ways to think about it. One is that there's particularly on a field like this where there's a funnel of activity behind these trees here around the pond. There'll be a thermal that'll form, it'll move through there, and it'll suck all the cold air, and then it'll regenerate and the next funnel comes. And that just keeps going on throughout the day. When it's more evenly spread out, here, 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 checkerboard again. And used to fly in Lafayette, Indiana, and I'd see that a lot more. And that was an interesting one. The buzzards there, it was so flat and there were no trees, they would set up search grids. And so if you looked off in the distance, you'll see a couple here, a couple here, a couple here. And then depending on what their buddies found, they'll group together. And so if it's a light thermal day, if one group starts going up in a good thermal, you'll see them converge on that thermal. And then one time I was in a thermal with a bunch of them, and great time, and they started scattering, and most of them went off to the south, but I had to come back north because that's where I was flying from. And one poor buzzer thought I knew something, so he follows me back up north, and all I did was land. And he's like, "Oh shoot!" And he had to flap to get back up to altitude. He was not very impressed with my carrying. But they'll set up in that grid pattern because that's sort of how the thermals are, and you'll see them off in different distances. But yeah, it's dependent on the day, and like down in the southeast, there's a lot more intensity, like Arizona, and there may not be very many thermals in a given day, but or at a time. But they'll be incredibly strong. And so that's really dangerous, because if you launch at the beginning of the contest or the window and you get in the air, or your buddies all get in the air and you don't, it could be 10-15 minutes before the next thermal arrives, because they're so intense. They suck in all the air there. And so it is really critical on some of those flight conditions to be in that one thermal with everyone else and then stay in it. And unfortunately, that means that you are way the heck downwind. They fly crazy downwind. And so, understand what the day's doing and, adjust appropriately. And in that case, yeah, absolutely. Follow that downwind. Get crazy about getting to it, make some dumb decisions about not getting your plane back. That's how you're going to win those contests, because there isn't another thermal. Around here, there's more thermals, but they're smaller. And so you could say, okay, I'll follow this one for 3-4 minutes, penetrate back up, get the next one. And that's a important thing when you're looking at a 10-minute window or something. You're trying to get a 10-minute flight. In 4 minutes, particularly on a day like this, you're going to be on the other side of those tree lines. You're going to be able to see your aircraft, and so you want to try to get as high as you can in that first one, and then get some momentum to come back upstream. And that's when you're in search mode again. And so you're looking for your buddies in a thermal, or your the birds, or the wind, the other things we talked about. But ideally, one of your buddies already penetrated upwind and found something for you. But you gotta make that call, and it's really hard to leave lift. One of the rules of thumb is never leave lift. Well, sometimes you have to, so account for that. Any other questions? Yeah. Uh-huh. Uh-huh. Yeah. Yeah, I don't see too much. Yeah, so when I think of sea breeze, what happens out on the water, the lake's big enough, and definitely the oceans, is it's really uniform relative to the land. There aren't too many thermals out over water, and so air that's coming off of that can be really humid, really consistent, really just not very thermally. But what's neat is when the onshore happens, so the land warms up and it pulls that cold air up off the water. Is that the right direction? I get them backwards sometimes. So it's coming in, and then in the evening, as the land cools off, it goes back out. And what's neat is there's a mixing that goes on, and you'll see pockets of that dense cold air mixing with the warm air, causing super intense thermals at times. And so it can be a good thing, particularly if you're right on the front of it. One of the biggest contests in the country has been in Poway, California, and it's north of San Diego, and it's inland enough that you get a lot of deserty kind of behavior. But then in the morning, the cold air has come in off the water and has really, you'll see fog and stuff, and then those thermals start popping, and it gets really active for part of the day. So it's a neat little sight. Any other questions on the thermals? They can last a really long time. The small ones we see down here are actually, when they form up together enough, they'll go up to altitude and form the white puffy cumulus we see. And so the full scale guys, that's what they're looking for. Those cumulus are typically 3,000 to 5,000 foot bottoms around here anyway. And so when the thermals form up, they keep going up, and they've got, any water that's in them will condense at the condensation altitude and form those clouds. And so those are actually giant thermals, and they'll last for all day, some of them. And so in full scale, they'll look for that kind of day, and they'll go up and they'll tow, and then they'll circle up into the cumulus, almost to cloud base, even into it if you want to be illegal. So that's they will go on forever. Around here, it's typically they'll stay together, in my experience here anyway. They'll stay together until I can't see them anymore, and beyond then it doesn't matter. If it's still there, you can't use it anyway. But I'll get 5-10 minute flight. Look out! We lost the camera. Too much frontal area for its mass. But yeah, they'll go. But sometimes thermals will get eaten by other thermals. I mentioned that at Muncie. You'll be in a perfectly good thermal, and then there'll be a thermal here and a thermal here, and your thermal will start breaking apart because these ones over here are stronger. They are more interesting, more attractive. The camera's pointing a little crooked. They'll chop it apart, and you'll be circling, gone. And I have that happen to me a lot in Muncie because I am a loner kind of guy, sort of a cowboy when it comes to thermals, and I like to find my own air, and that's good unless everybody else is in a different thermal. And when your thermal breaks up and they're all still in a good thermal, sucks for you. And then vice versa, if they're all together and their thermal breaks up, well, now they have 5 guys to go find the next thermal. Good for them. And so pack flying can be a really useful strategy when you're at a contest with a bunch of different people in it. So yeah, I don't see that as much around here. Of course, I don't fly with a lot of other people, and so maybe I don't notice it as much that there's other thermals that are still going up, and mine isn't. But it's definitely a Muncie thing. Any other thermal questions? Yeah? Ready to start talking tech? There's another one. Yeah. So it's that vector thing, that vector math. So if I have a couple of indicators out here, certainly the windsock is pretty good. The longer tails give you a better sense of what the air is doing, but you're going to see it point with the wind, the prevailing wind, and then when a thermal comes, it'll sort of blow over to that side. Or if it's right over top of it, the flag will fall down. And so that's what you're looking for, those different wind vectors. And if I like to have a couple of poles up if I can, one to each side of the runway or the field, and then you can decide if you want to go left or right sometimes. So that's what the thermal poles are useful for, just like a windsock or what's on the end of your transmitter. Any other questions on that? So next on my agenda is probably to talk about, let's go ahead and talk about a contest a little bit. And then I can talk about history a little bit after that. So hand launch started out in the United States pretty much, as hard as that is to believe. A lot of the soaring seems to come from Europe. But the Americans are the innovators, and then the Europeans tend to make contests out of things and competitions and write the rules. So I think cowboys. But hand launch used to be it started out sort of in California, because that's the only place where the thermals were strong enough to carry the gear aloft that you could launch with your hand. So back in the old days, you used to launch sailplanes with a winch or a bungee cord. And the winch, I actually have one in the truck, is a spool of thread, and it goes out to a pulley and then comes back. And you hook that pulley or that cord to your plane, and you step on the pedal for the winch, and it pulls the string around the pulley and pulls the plane up in the air. And so that's winching up. And that was really common. And then you'd see the bungee, so almost the same thing. You have a bungee with the string on it, stretch it back, you let go of the plane, it goes. And so that was really popular, 60s and 70s, I think. Big poly planes, and then they started putting more servos in the wings. And as the radio gear got lighter and lighter, they'd start building smaller planes. And then the other really big thing, particularly in California, was slope flying. So slope flying is that cold, uniform water coming off the ocean, hits the land and slopes up. And that is really useful because now there's this up. And you can, if my leg's the slope, you can fly out in front of the wind and get lift with your glider going back and forth on that slope. and you can do aerobatics, loops and rolls and all kinds of things. And so a lot of California guys had those slopers, and they would do racing with the slopers. And they found that different size planes flew differently, and it was sort of fun to have competitions with different size planes. And one of the smallest sizes was a 60-inch sloper. And so there were guys who had these 60-inch slopers. And if it was a light day on the slope, you'd build a lighter sloper so it'd still stay up. And so just 1 or 2 mile an hour wind off the ocean with a light enough plane, you could slope soar that. And so there's a convergence of that 60-inch racer that was really lightweight and those guys flying winch. And they realized that they could, and on the slope you only ever throw your plane. But they realized if they had a light enough sloper, they could throw it and catch one of those thermals that they're catching with the winches. And that was sort of how hand launch was born. They started building lighter and lighter planes that could perform in the thermal that they could then throw overhand. And so that picked up, and in probably early 70s was the very first hand launch contest, maybe 80s even, because the gear was just huge. You know, we're talking NICADs and S48 servos and you know, big stuff. And so the hand launch wasn't super practical. And then when I started getting into it in the 90s, there's actually a really popular company down in Dayton area, DJ Aerotech. Anybody heard of DJ Aerotech? Jim has. Yeah, that was a long time ago. Don and Joe, I still see Don posts on Facebook. I haven't seen Joe much, but they're still alive. They had these neat little planes called Monarchs, and they flew just like a Monarch butterfly. A lot of polyhedral and V-tail, and super light. And they were able to take the lightest gear available, and a lot of camber in the foils, and actually fly around and launch for. Jeez, it's windy out here. Everybody staying dry, or is this silly? Good enough. Okay. Okay. So sorta. I don't know if it's better downwind or not, but you're welcome to find another seat. So that convergence of the gear and the practicality of different things made it where hand launch became practical. And so early 90s, you'd see some built-up planes, balsa with monocoque, and then later on it was composite. The DJ Aerotech were balsa over white foam, and that was super fun. And then you know, the Nats would have 30, 40, 50, 60, 70 people in them in the 90s, and that was super fun. Over in Muncie. Woo. And so you'd see, and then you know, people knew what high performance looked like in that the bigger planes, the winch launch planes, had the higher performance airfoils on it, and so the 2 meter, 3 meter RG-15 airfoils, and then there started being Selig did some really interesting low-speed wind tunnel testing in the 90s and started developing some new airfoils with a little higher performance. And so you'd see that, and then it slowly penetrated down, and we started designing some new airfoils for the planes, and using the available technology to increase performance. And so the big contests were the Nats, and Poway was super big because that's sort of where hand launch had started there in California. And we started seeing more and more composite planes, and almost all these small companies doing stuff. But still, the rules were in the AMA rulebook. Category 441 was hand launch, and we just started doing more and more. I mentioned my contests out in Seattle. I moved out there in 1997 to work at Boeing, and there was a pretty good cadre of winch pilots and a few hand launch crazies. And one of them, Steve Cameron, flew the Orbiter built-up plane. He came to the Nats and actually won the Nats. And Dodgson said, "If you win the Nats, I'll kit this plane." And so he won the Nats, and poor Dodgson had to kit the plane. I built one. It was the most fiddly, lightweight planes I'd ever built. And boy, I worked really hard, and that baby came down to 11.5 ounces. What's that in grams? A lot of grams. 330. So that ballast vortex I was flying this morning, it's about 350 with the ballast in it. So so I would never fly that Orbiter in this wind. But we started getting more and more technology, and it was all overhand. So we had these contests, and in about 96, 97, Harold Locke out in Seattle realized that if you held on to the wingtip of the plane and you do a downward motion and up, you could throw it really high. Unfortunately, you could only get about 44-inch wingspan because your arm hits the ground eventually. So that was called sidearm launch. So you're like this, and you go like this, and you throw it up in the air. And he designed a plane called the Tactical Air, and it was a cool little plane that you could sidearm launch, and you could launch higher than they could throw overhand. But with the limited wingspan, your performance wasn't as good. So you could use it as a tactical weapon to wait for the other guy to find the thermal, and then throw higher than him into the better air, high up in the thermal, and still win the contest. So that was sidearm launch. Now, a friend of mine, Dick Barker, had seen us doing the sidearm launch, and he's like, "I wonder if I could do that with a full-size plane if at the poly brake I put a little tab." And so he's holding it at the poly brake halfway up the wing, and it was sort of successful. And then Dick had thrown discus in college, and so he knew about spinning around, and he knew what the footwork sort of was, kind of thing. And at some point, that sidearm thing with the thing, he spun all the way around, and wow, he could really throw it far. And then he said, "Well, what if we held on to the wingtip? That'd be even longer." So you got more distance out to where the center of mass is, sort of a slingshot or an atlatl kind of thing. What if I held on to the wingtip, just the wingtip? And that's when Discus Launch was born. And so Dick was probably in his 60s at the time, not in great shape, smoker, big pot belly, and he would spin around and launch that plane higher than I could throw overhand. And I'm like, okay, there's something here. And so it was pretty obvious to most of us that was going to be the thing, although it didn't catch on right away. Dick would go out and proselytize at different contests, and people would sort of be impressed, but he wasn't a great pilot, and so it didn't quite catch on. And then the plane wasn't really super well designed. I have an older Discus Launch. I'll show you that if it stops raining. And some of the early innovations. As you throw sidearm, there's a lot more side forces on the tail, and so you have to change your tail design. And the harder you throw, the stronger that has to be. And so there was some real development work that needed to be done to make those practical, because when he started out, it was sort of an overhand design. Your tent's falling apart, Alexi. That was loud. Is it not popping? Did the thing come out? Okay. So Dick Barker has, there's some other people that claim that they did the discus launch earlier, but it really caught on after Dick did it. So I give him most of the credit. So he's gone around and up north we'd adopted the discus launch, and Phil Pearson started designing some planes that ultimately became the Encores. And then it really caught on when Joe Wirtz, who is a world-class competitor, he's won just about every soaring event there is over 20 years. He's California native, worked at Lockheed Skunk Works. He was out at his club field throwing his hand launch, and he was a really good thrower, even though he was left-handed. He was really really good pilot, but also a strong thrower. And he was getting out-thrown by overhand by a guy who'd only been flying a couple years with the discus launch. And Joe says, I'm not going to put up with that. And so he called up to Phil and got some encores down for Poway. And so, like, one year, probably 2002, there were 10 people throwing discus, and by 2003, everybody was throwing discus. It was just like that. And that was how, when it took over. And that's actually when the Europeans got interested. They came to Poway, saw how successful and useful it was, and adopted it, and hand launch became a real thing in Europe. And that's when they wrote the rule book, and F3K was invented. Jim.
I don't know if you were aware of ICD, the first nationals contest for discus launch.
Okay.
And Paul Siegel won that.
Yeah.
Thing called
Disco Girl, yeah. Yeah, that's
interesting time.
yeah, it sure is. So
People were trying to circumvent the rules by finding all different devices along planes.
yeah.
It's pretty interesting time.
Yeah, and fortunately they didn't just rule it out. There was talk of that. I'm happy they didn't, because it's so much easier on your body to discus launch than to overhand. And so I think that was a real plus for the community, is that they didn't rule that out. But yeah, Paul had seen the discus out in California. He'd come to Poway, and he used to fly Monarchs, and then he put it together that this is the way to go, and he got a plane together and flew it at the Nats and won that. What was that, 2002? Or 03? It's a blur. Yeah. So, and then, like I said, the Europeans did the rules. F3K, you'll hear. F is for FAI, and 3 is for soaring events without motors. And then K, because they did it in alphabetical order, and K was the next one that needed a name. So J was right before that with the tow launch thermal duration, and then K was after that. And then yeah, so that's F3K, and it's taken over, and the technology keeps moving. The planes don't look as different as they were in the early days, new ones versus old ones, but there's been different airfoil development that's gone on in different style. And then everything's about getting the weight out. That's really important, but also getting the drag down and moving towards that ultimate design. Any questions on the history there? Lots of good stuff. I do like to scratch build airplanes and repair things and everything in composites, and composites are a real exciting place for me. I'm contemplating doing a clinic in my garage maybe this winter on at least repairs, if not hand launch construction. Keep an eye out for that. Yeah, as both Daniel and Alexi will attest, I can repair just about anything. So if you do crash your expensive composite plane, let me know. Don't throw it away. Let's at least take a look at it. It's likely repairable, and we may not add too much weight, really. I've been pretty successful with the repairs of late. Oh, come on. So any other questions on that? Okay, let's talk contests a little bit. Have enough fun, Larry?
Back up a little bit.
Yeah.
Somebody just starting out. Your recommendations for.
Yeah, let's talk about that.
Who do they you gonna put your phone number out?
Oh yeah. Yeah, absolutely. It's on the RC groups already.
What do you recommend?
Yeah, so unfortunately that's one of the poor spots in hand launch, in soaring. There aren't a lot of beginner discus launch planes, but as far as sailplanes goes, the real exciting area in my mind is the electric launch whatever. If you're just a beginner, the Radian is a really nice choice. I got one in the car. I could show it. It is deathly afraid of this wind. But Radians are really nice. There's some of the built-up sailplanes with the electric motors on them, and learn to thermal. Get that under your belt. Learn to fly, and then you can move into some of the hand launch stuff. The best real entry into hand launch is a used plane. If you can get one, us top-end competitors get new airplanes every couple of years, so you can sometimes find them through your local friends. I got one for Alexi because Oleg's battery died when he threw his plane and crashed it really bad, and he didn't want to repair it, so I said I'll repair it, and so that's what Alexi's flying now. I got a used one for Daniel out of Seattle, my buddy Rick there, and then he's going to get a second one for me for my 2-year-old planes. So that's a real good path. I'm going to make a list, and I'll put it on RC groups of the different planes that we found that are available out there. But yeah, getting a used one's a really good way. But then, it's hard to say who's got reasonable intermediate planes, because they'll last for about a year and then they'll stop making them, and so it's really hard to recommend. But they're out there. RC groups is where everyone in hand launch hangs out. So there's a DLG HLG page. Just go there and start paying attention. Like I said, it's unfortunate there isn't a great answer for the best beginner DLG, but it is where we are. This is lovely weather. Whose idea was this? Contests or more about DLGs, sailplanes? I sort of want to show my plane, so let's talk about contests for a bit. Traditionally, 5 2-minute flights in a 10-minute window is where hand launch sort of started, and there's actually 10 1-minute flights originally, back when soaring was harder. But the basic premise with hand launch is they're going to start a timer, and that's going to be your window. And, well, go ahead and fold it down. It's just going to blow over again. But they'll start a timer. It'll be 10 minutes usually for a round. Sorry, that's lunch coming. Yeah, so they'll start a timer, and you're going to fly for 10 minutes. And the rules are you're allowed to take a timer out there with you for most of the rounds. And the timer will also be your caller and will help you find air. And if you have a problem, they'll let you know, and they'll also let you know what your time is. So on 5 2-minute flights, you're going to launch, and you're going to try to get as close to 2 minutes as you can. And sorry, lunch again. The so you launch, you're going to fly around, you're going to try to find a thermal. 2 minutes is a little long to float down, even with the really high launch. You're going to thermal, and then you come back in, you're going to land really close to 2 minutes. Now, with the 2 minutes, there's no penalty for going over, but you don't get any credit for any time over 2 minutes. So you're going to, ideally, you come down at 1:59, you're going to grab it, you're going to launch again, go back up, thermal around, and you're going to try for that next 2-minute flight. Come in, grab it, back up. So ultimately, you'll get 5 flights, and they'll all be about 2 minutes. And you get scored by how close you got to 2 minutes on all of those, your total time not exceeding 2 minutes. And then everybody who's flying in that round with you, you get normalized against their score. And so that's how the 5 2 minutes goes. And then similarly, there's a 1 2 3 4-minute flight in any order. So you're going to launch, you're going to try for your 4-minute flight first. But if you don't get your 4 minutes, you wait, or you land at that 1 minute, come back and throw again and try for a 4 again. If you don't get the 4, you try for the 2 or 3. And you come in, and then ultimately, if you don't make your times, that's your best 4 flights, not exceeding any of those limits. And then one of the other rounds is called All Up, Last Down. That one's a little different. Your timer stands on the side of the field and just watches what you get. And so that one, you're going to try for a 3-minute flight. And in that round, the timer counts down, and everybody has to launch right at the buzzer or within 3 seconds of the buzzer. So it'll go 5, 4, 3, 2, 1, and then the buzzer's 3 seconds long. You gotta launch in that time. And then you try to get a 3-minute flight on that. And everybody does whatever they get. They come in and land. And at the end of 3, they'll come in and land. And there's a 30-second landing window. Planes have to be on the ground by the 30-second landing window. That's true of all the rounds. And then in the All Up, Last Down, there's a 1 minute you have to stay on the ground. And then there's another 5, 4, 3, 2, 1 buzz, and everybody launches again. So you do All Up, Last Down 3 times. And that's the All Up, Last Down. Again, you don't have a timer for that one. That one's pretty neat because you can do that without a timer effectively, just on your radio. That's a really good one to practice, particularly if there's just 3 or 4 people out at the field with you. You can enjoy doing All Up, Last Down. Another one of the contests is poker. So poker, you have the option, you have to elect how long you're going to fly first. And so you You say you can, you want to get as much of a 10-minute round as you can, and you're only allowed electing 3 flights. So the cool guys will call a 2-minute launch flight. They'll find a thermal, and then they'll land and they'll say all in, which means I'm going to fly to the end of the window. And so then they'll throw back into that thermal and fly for 8 minutes and get nearly a perfect score. Unfortunately, if they don't get that all in, they get only the 2-minute flight. And then the real good guys, the real pros who don't understand statistics very well, will launch an all in at the beginning of the round. And that's the most points you can get. But then you got to find 10-minute air and stay in it the whole time. Odds are not great that you're going to do that, but that is the highest score you can get. So that's the gambling one. What other tasks are there? There's a 7-minute window, which is, I think, one flight in 7, and then there's the best 2 flights in a 10-minute, so 2 5-minute flights. Is that one? Well, anyway, there's a bunch of rules. You should look them up. I usually review it before I go to the contest. And the closest contests around here are in Detroit. Detroit has a pretty much monthly event. They have one coming up next weekend, actually. If anyone's super interested, you can make your way up there. It's a little park north of Detroit. They have a website. They don't list on RC groups, but they do have a website with all their stuff, and I can give you information on that. Let's see. Jeez. That's you. How's the radar look? Anybody got it up? That's a big glob and blah.
Sandusky looks pretty heavy. Fortunately, electricity seems to be going south.
Yeah.
So more lightning yet.
Yeah. I'm not thinking it's worth cooking lunch. I don't know about you all. What's behind that, Jim? More rain?
Yeah, about 2 hours out.
Yeah. 2 hours now. Any questions on that? How about talk about strategy? There's my lovely fiance, Kristen, with our hamburgers and hot dogs, all frozen, of course.
You can see that cloud deck out there. That's what's holding it.
Yeah, that is not much fun. Okay, just a little quick here. My tiny discus launch plane. Now I'm left-handed, so try not to get too confused. Turn this down a little bit. The wind's coming this way, so you're going to be with your right shoulder to the wind, your left shoulder to the wind. I'm going to confuse myself if I do that. And the real trick is the first part of the spin isn't super important. It's there to get your plane lined up for the end of the spin. So I'm going to take a step, come around, take a step forward, and then when I'm coming off of this knee, I'm trying to come as far around as I can, but still stay coiled. And then see how far I'm coiled. I want to be really coiled back, and then it's all about this speed here into the launch. And it's not easy. I won't lie to you. But once you get it down, it comes, and then all that power comes through that coiling of your body and your hips. And then ideally, your body would be a bullwhip, and it would just naturally slingshot up there. Well, your body isn't as limber as a bullwhip. And so you have to treat your muscles to simulate a bullwhip kind of action. And so that's what I try to think of. And so I'm 1, 2, 3. You want to demonstrate right-handed, Alexi? Back here. But it's that snap that really gets it going in the air. Well, guys, I think I'm going to call it. You can come back to my house. We can grill these on the grill. Or we could just wrap it up and call it a day. Lexi's coming over for sure. Sure. But
we're having a new roof put on the house today.
oh, nice.
So we gotta head home and see what's going on.
Do you plan to do anything like this again, like 3D metal?
Absolutely. I would love to do this again after this rain out. Kristen's umbrella is not very strong. This is the gentle lady of umbrellas. I've just called off the event, Kristen. So you're just in time. Just in time. I will we'll get some of the stuff back in the shed and I'll clean up.
Thanks for all your efforts.
Oh yeah. Well, yeah, we should definitely in the summer, August or so, we'll try again. And then I mentioned building clinic down the road. Do you have any contests, Jim? What do you guys do? Not really.
Yeah, it's mostly sloping and flat field thermal flying with electrics.
Okay.
Where's that at?
We're in Lodi. It's American Airlines Gas Model Club, but we've got a real nice field there. And there's a good number. There's a good number of guys with electrics. A couple guys. We got 3 or 4 guys that do DLGs, but not a whole lot. Much older crowd, so most are going to electric.
Oh yeah.
So,
yeah.
But some of us diehards are still going to be out there throwing them. So.
Oh.
But nothing organized or structured.
Yeah, I don't. Gavin Trussell's guy down in Columbus area. He was pretty active. He hasn't been as much. He does more of the F5J now, the electrics. And then what's Tom's last name? Seiler was big into DLG, and he's really gotten out of it. But you'll see him occasionally on RC groups.
We still occasionally have our soaring Sundays, we call it, where I'll bring out a winch.
Okay.
You can bring any kind of electric sailplane glider, and we try to make it hospitable for anyone, beginner and whatever. So
Yeah,
we'll publish that if it comes up again. It's probably going to be in August.
Yeah.
that's awesome.
But thanks for your efforts.
Yeah, well, I love holding a party, and there's another field in Bellevue, which doesn't have all this traffic, and I think that's going to be the better spot for a contest. It's about 25 minutes from here, but it's south and maybe not even that far. Yeah, maybe. But I think if you go straight there from Cleveland, it wouldn't be as far as coming here and then going there, because it is west from here. What's that? Yeah, they're the something Valley, Huron Valley RC Club. Yep. No, they just fly power, but I fly gliders there. Nobody's been there. When I'm the only guy there, there's all kinds of sailplanes. But it's a big open field in most of the directions, and there's grain silos with nobody there in the one to the east of the field. and then they have a nice permanent shelter and a clubhouse thing. So, yeah, it's pretty nice field for this. And they also do astronomy at night. So, Alexi's a shoe in there. That's
we have night flies pretty frequently.
oh yeah.
And our field is pretty much a private field, so it's locked, it's gated. But we'll be glad to help if someone wants to come out. Just let us know. We can open it up.
Yeah, that's
We have
awesome.
some events.
Well,
Indoor flying too. If
Yeah.
you're not indoor.
well, fantastic.
Now,
Okay.
isn't there a Lorraine club that's close by?
One of these guys is Lorraine. They still here? Lorraine Valley or Lorraine County RC is a club. I don't know if they're doing any soaring. Yeah, they took off. Fairweather Friends.
What are the big differences between the 1.5 and 1?
In 1 meter,
Yeah.
performance
Okay.
is a big part of it. There's an equation. There's a lot of equations,
Yeah.
but the performance of a wing is you multiply by the span at the end of the equation in the performance numbers, and so span is always positive. And if you look at the full scale, they're humongous, and so that's a huge advantage. And they limited hand launch just sort of because they could. I've seen some 2 meter discus launch. They aren't terribly practical. It doesn't mean that they couldn't design it better, but right now that isn't super practical. But the 1.5 is really good. But when you shrink down to 1, they just do not have the performance. And
1 meter and 1.5, the difference is enormous.
yeah, it's more than just the foils. That span reduction just reduces the overall efficiency of the aircraft.
Yeah.
And it's an aerodynamics thing, really, and it's really interesting. Yeah, but it's also practically it's real. It's very real. But
One of the places you're looking for information,
Yeah.
you can start with RC. There's a lot of information. Stuff you need.
Yeah. There's a lot of information.
too much information. Yeah, that's the thing with RC groups, and you have to dig in to get what you want, and that's good and bad. And there's a lot of helpful people on there, and there's some trolls too, and so you have to wade through that. I like RC groups better than Facebook though. Facebook is too much misinformation, and then you can hardly get back to something you read a week ago, and it's harder. But yeah, I think Lexi has handouts. I think you can get those to people without blurring them too much. Yeah, maybe they are. Take a handout, and then I also had some 3D printed planes for you to take home.
When you put them in the front.
Take one home. If you don't want them put together, find a kid who does. I got plenty. The black ones are PCTG, which is a little more resistive to thermal issues. Take a couple. Give them away. What's that? Of course I printed these. And they end up looking like, I got one in the front. I'll show you what they look like.